MS Ramaya University of Applied Sciences.
Hello friends, with this experiment we are determining the compressive strength of a given concrete mix. Apparatus: cube molds of 150 mm, iron pan to mix concrete, weighing balance, trowels, tamping rod of 16 mm diameter and 0.6 meter long with bullet point at the lower end, measuring jar, compression testing machine, that is CTM. Compression test is the most common test conducted on hardened concrete, partly because it is an easy test to perform and partly because most of the desirable characteristic properties of concrete are relatively related to its compressive strength. One of the most important properties of concrete is its strength in compression. The strength in compression has a definite relationship with all the other properties of concrete, that is, these properties are improved with the improvement in compressive strength. Hence the importance of the test. The standard specimen measures are cubes 100 into 100 into 100 mm or 150 cross 150 cross 150 mm. Procedure: sampling of materials. Samples of aggregates for each batch of concrete shall be of the desired grading and shall be in an air-dried condition. The cement samples on arrival at the laboratory shall be thoroughly mixed dry either by hand or in a suitable mixer in such a manner as to ensure the greatest possible blending and uniformity in the material. Proportioning. The proportions of the material, including water, in concrete mixes used for determining the suitability of the materials available shall be similar in all respects to those to be employed in the work. Weighing. The quantities of cement, each size of aggregate, and water for each batch shall be determined by weight to an accuracy of 0.1% of the total weight of the batch. Mixing concrete. The concrete shall be mixed by hand or preferably in a laboratory batch mixture in such a manner as to avoid loss of water or other materials. Each batch of concrete shall be of such a size as to leave about 10% excess after molding the desired number of test specimens. Mold. Test specimens cubical in shape shall be 15 cross 15 cross 15 cm. If the largest nominal size of the aggregate does not exceed 2 cm, 10 cm cubes may be used as an alternative. Cylindrical test specimens shall have a length equal to twice the diameter. Compacting. The test specimens shall be made as soon as practicable after mixing and in such a way as to produce full compaction of the concrete with neither segregation or excessive lightness. Curing. The test specimens shall be stored in a place free from vibration in moist air of at least 90% relative humidity and at a temperature of 27 degree plus or minus 2 degrees Celsius for 24 hours plus or minus half an hour from the time of addition of water to the dry ingredients. Placing the specimen in the testing machine. The bearing surfaces of the testing machine shall be wiped clean and any loose sand or other material removed from the surfaces of the specimen which are to be in contact with the compression platens. In the case of cubes, the specimen shall be placed in the machine in such a manner that the load shall be applied to opposite sides of the cubes as cast, that is, not to the top and bottom. The axis of the specimen shall be carefully aligned with the center of thrust of the spherically seated platen. No packing shall be used between the faces of the test specimen and the steel platen of the testing machine. The load shall be applied without shock and increased continuously at a rate of approximately 140 kg per square centimeter per minute until the resistance of the specimen to the increasing load breaks down and no greater load can be sustained. The maximum load applied to the specimen shall then be recorded, and the appearance of the concrete and any unusual features in the type of failure shall be noted. Data collection and tabulation is as shown in the table. Data collection and tabulation is as shown in the table.
Hi students, today we will start discussing the tests on hardened concrete. There are three important tests that we are going to do on hardened concrete. The first is the compressive strength of the concrete, the second one is a flexural strength of the concrete, and third one is a split tensile strength of the concrete. So we are discussing now the compressive strength of concrete cubes. So the apparatus required for compressive strength is the CTM, that is compression testing machine. This is a concrete cube mold of having the dimension of 150 mm width, 150 mm length and 150 mm depth. Along with that, we require all the materials which is required for making a concrete, that is the fine aggregate, cement, coarse aggregate and the water. So let us go through how this is done. The second step is preparation of mix. As of now, we've taken 2.5 kg of cement, 5 kg of fine aggregate and 7.5 kg of coarse aggregate, which comes to ratio 1:2:3. We generally do it for M20 grade concrete. For the first trial, I am considering the water cement ratio as 0.4. We start mixing the concrete. First, what we are going to do is we make sure that the concrete mixer is on the inner side, it is smeared with the oil. So first what we will do is we add the coarse aggregate. So we are going to add the coarse aggregate to the concrete mixer. After coarse aggregate, the fine aggregate will be added. After this, the cement will be added along with the water which is prescribed for this particular mix. Add the water. We are pouring the entire mix of concrete onto the tray. After mixing the concrete, we are going to make sure that the oil is smeared inside the mold, and we are going to apply 1/3 layer of this mold with the prepared mix. After placing 1/3 mix, we should compact this 1/3 layer with 25 tampings, or what I am doing here is I am using the table vibrator for compacting the mix. The second, third layer will be added. and the final layer will be added. Like this, the cube is prepared. So here we are just doing only for the one sample. If I just go for the IS requirements, minimum 6 samples has to be casted for one particular testing. Okay, right now I am just doing only one sample. What we are going to do is, we are going to allow this mold as it is for 24 hours. We'll air cool it. Then what we are going to do, we are going to demold the shutter. After demolding the shutter, we are going to keep it in curing for 28 number of days. After curing it for 28 days, whatever we are going to get a cube. The dimensions of the cubes are measured. So L, B, this gives you the cross-sectional area of the cube. Suppose this is my casting surface. I need to place and apply the load on the other side, not to the casting surface. What I am going to do is, I am going to subject this particular cube for the compression. After subjecting this for the compression, I am supposed to operate the compression testing machine. So what I am going to do is, I am going to bring it to the compression mode. So select operating mode. It asks for mode 1 is compression, mode 2 is flexure, and mode 3 is prism setting. What I am going to give you is a compression. I put enter. Okay, it asks unit is SI. Yes, I want it in Newton per millimeter square. Okay, it tells you the model, what is the maximum capacity of the compression testing, 2000 kilonewton. So what we are going to do is, after this, we are going to close the shutter, because there is a chance that under the compression your cube particles may hit the tester. After doing this, what we are going to do, we are going to tighten the load and we are going to keep it in the center. We remove the emergency. It will be initially on. We are going to remove it. Okay. We are going to start the pump and we are going to run the testing. We are applying the load. What we are going to do is, we are going to take up the maximum load of failure. How we are going to observe? So if you observe, there is an increase in a load and decrease in a load. Okay, so already you observed it, it's went to 500 and so it gives an indication that the sample is broken and it's going to give you the peak load, that is 556.2 kilonewton. Okay, so I already fed the cube dimension, that is 15 cross 15, that is 225 cm square. Okay, we are having a provision that it automatically gives the compressive strength, that is 24.72 MPa. So this experiment has to be repeated for 3 number of samples or 6 number of samples. The average compressive strength reading will be considered, that we are going to call it as the grade of concrete. So it is 24.72 for this particular sample. So we do the average of 6 samples or 3 samples, the average compressive strength will be noted down for that particular grade of concrete. Observe, you find the cracks, appearance of the cracks on the concrete cubes. So this completes the compressive strength of concrete experiment.
At MSR UAS, we spark your imagination unlike any other.